Hi students, this is Dr. Bennila from RM Engineering College. So this is the first lecture in the series Signals and Systems. Basics of Signals and Systems. What is this course all about? What I am going to learn in this particular subject. So the objective is to know about signals, systems along with their basic properties and classifications. What I will learn about from this subject. So I'll be able to analyze the properties of signals and systems at the end and learn the skills and tools needed for the analysis and understand how computer process the signals and systems. What are signals? Signals are defined as physical quantity that varies with one or more independent variables. So signals are the one which carries information. So example, human voice, radio and television signals, biomedical, engineering signals. If the signals depends on one independent variable, it is called as one-dimensional signals. Example, speed signals, daily temperature, etc. So speed signal depends on the frequency and daily temperature depends upon the time. If the signal depends on two or more independent variables, it is called as multidimensional signals. Example, digital photograph. So, depending upon the information, I can classify the signals into two. One is continuous time signal, other one is discrete time signal. What do you mean by continuous time signal? So, continuous time signal can be defined for every instant of time. In continuous time signal, it is continuous in amplitude as well as time. So, we can denote the CT signals as x of t. So, example. So, this is an example. Sinusoidal signal is an example for continuous time signal. So, always your x-axis will have time and y-axis will have amplitude. So this is continuous, right? So amplitude and time is continuous. So this is another example for CT signals. So this is nothing but an ECG signal. So this is also a CT signals. Next is discrete time signal or DT signal. In DT signal, it is defined for discrete instant of time. Here in DT signal, it is continuous in amplitude and discrete in time. It is denoted by x of n. Example, so here x-axis will have n and y-axis will have x of n. So here the signal is defined for discrete instant of time. So time is discrete, amplitude is continuous here. Now we have studied about signals. So now we'll see what are systems. So systems are defined as physical device that operate on signals to transform one signal into another. So transform can be manipulate the signal, change the signal, record, transmit, etc. here. So this is the block diagram representation of systems. So x of t is the input signal, y of t is going to be the output signal. So the transformation will take place inside the system here. So we can read it as y of t equal to transformation of x of t. Or the output signal is nothing but the transformation of the input signal. So some examples for systems are amplifier, radio, television, modem, computer, etc. So now let's have a basic example here of a system. So your music CD is an example, practical example. So here the system, the input to the system is going to be music, the music which I am going to record the CD, and the output will be, I will be listening the music at the listener's side. So this is my system here. So I am going to analyze the system, right? So how this music which I am going to give it in the input, so how I am going to listen that music at the listener's side as an output here, right? So music, the input, and the music at the listener side is going to be the output. So first the music should be written into the CD, the first part. The second part, the music which I have written in the CD should be heard at the output side, right? So first I'm just giving the input music to the recorder. So that time the music will be of analog signal. So it's x of t. So the music which I'm going to write into the CD, it should be of digital, right? So I'm going to convert this analog signal into a digital signal using A to D converter. Now I got my digital signal x of n. Now I am going to write it into the CD using the optical disc writer. So I will be writing the music into the CD. Now the retrieving part. So if I want to read the music from the CD, what I will do? So from the I will be using the optical disc reader to read the music. So this will be of your digital signal. So always we'll be using the analog, the signal which we listen is going to be analog signal. So I'll be converting the digital signal into analog signal using D to A converter. So now my digital signal has been converted into analog signal x of t. Then I'll be giving this as an input to stereo. So I'll be listening the music at the listener side. So this is a simple example for a system music CD here. Right, so assignment for today's session, name any two systems that process the signal, like the example we saw now. Draw the block diagram to show how the signals get transformed. So the entire block diagram including the signals here. Thank you students. So you can reach me through my blogspot and YouTube channel Bennila. Subscribe it for getting the updates.